My name is Matt Johnson. I'm a solutions architect in the AWS public sector team. Just go back a couple of slides to talk about the breakout areas. So we're very lucky to have Rodrigo Roca over from the States. He's principal BD or biz dev for the serverless team. So he's around until around about 1:30 today. The two sessions we're running, the second session is an invite only where a few customers will be talking about explicit or specific projects. The first session is available to anyone who signed an NDA today and wants to talk sort of in general, or if you want a conversation that's not under NDA but just wants some one-to-one time with, that first session is the one to use. But we're also lucky to have not only Matt Lewis from DVLA, but some great sessions as well from Ryan and Carl. So I really encourage you to go to those as well if you can. Okay, serverless transformation. So really what we're going to cover three things today from my point of view. What is serverless, where we are, and how AWS can help you with the serverless transformation. So what is serverless? Really, it's all about building and running applications without having to worry about infrastructure, and in particular, without having to worry about servers. So if we look at how the evolution of computing has happened over the last 30-odd years, we started with physical servers and data centers. I think everyone's sort of probably come from that background, and that's great. That's where it started. What we've then moved is we looked at virtualization within the data center, and that enabled us to get some economies of scale. It enabled us to compress some of the infrastructure onto virtual machines onto a fewer number of physical servers. But it was still management of both the hypervisor and the physical and the virtual machines on top. And then we moved to virtual servers in the cloud. And so this is a service that within AWS we call EC2, or Elastic Compute Cloud. And that gives you all the flexibility of virtual infrastructure without having to worry about your data center, without having to worry about physical kit. And each progressive step was better. So as we looked at it, physical, you had to manage everything. Virtual, you tried to abstract it a little bit. Virtual servers in the cloud, now you're in a position where actually you don't need to worry about anything other than the virtual machine. It provided high utilization, faster provisioning within, obviously, VM using vSphere, things like that. Disaster recovery, things like high availability. Independence from hardware, you could take a VM and abstract it. And similarly, within the cloud, that took another level of abstraction away. So you no longer had to worry about infrastructure. You could exchange CapEx for OpEx. You could scale on demand. Your scale wasn't limited by the physical kit in your data center. You could buy resources, and a lot of our conversation yesterday was talking about some of the benefits of that ability to scale elastically. Obviously, you don't have any issues around physical maintenance or data center maintenance, and well-architected designs can give you far better availability and fault tolerance. But there are still limitations. You still need to manage that virtual estate. You still need to plan and manage your capacity and utilization. You still need to size your workloads appropriately, whether that's your disk I/O or whether that's your CPU and RAM capabilities for a particular instance or application. You still need to design and architect how you're going to get your high availability, whether that's load balancing or clustering, whatever it might be. And it's still expensive to run intermittent jobs. You still need, if you just want to run something very quickly and then shut it down, there's still a cost to pay for that, whether it's in time or money. So we're now thinking about the evolution to serverless. And this is effectively how we can reduce some of the friction of IT management and allow us to scale quickly and rapidly based on code. So it's effectively provisioning all the compute capacity you need without having to worry about the underlying compute. And really, the tagline for that is, no server is easier to manage than no server. So once you have to worry about just the code, just the compute application side, all this goes away. You don't have to worry about the provision and utilization. You don't have to worry about the fault tolerance as a managed service. We worry about how the serverless compute engine scales in the background. We worry about how we patch it and manage it. You concentrate and focus on your code. And the key thing to take away from this is that it's delivered on demand. So when you're not using it, you pay nothing. You have nothing running. It's just there as code. When you need it to run, events will then trigger a particular compute. The process will run, shut down, and you've only paid for what you use. So let's just build this out and show how this works. So, events. This could be in response to a particular API call. It could be in response to somebody putting a file onto an S3 bucket, whatever it might be. Whether that's one event or 1,000 events, we worry within the Lambda capability how we scale that. So if it's run one, we run one Lambda function. If it's 1,000, we scale up. We run those in parallel. You only pay for the Lambda functions that have been used. Really key important point. You don't have to worry about any of that scalability yourself. And there's some key building blocks for serverless. So I've talked about Lambda. So Lambda is our compute on-demand service, I suppose is the best way to call it. What it means is you can write code, and that code can be in Python, it can be in Java, it can be Node.js, or recently it's now supports C#. You write your code, you package it up as a function, you upload it to the Lambda service, and then it's available to respond to events. And that Lambda function can make calls into any other part of our AWS infrastructure. So we have more than 70 services that we can talk to, but some of the key ones we've called out here are ones that are also serverless. So S3 is our object storage service. Again, that's a managed service. You don't have to worry about that. You just put objects in there. We worry about the scalability, the durability of that service. DynamoDB is our NoSQL database service. We handle the scale out, the scaling of that. We handle how the data is replicated, how it's stored resiliently. Amazon API Gateway is our managed API gateway service. This allows you to present APIs out externally. We worry about the scale of that. You just decide on the API definitions and how you're going to present them. To allow loose coupling of services, we have things like our queue service and our notification service. These allow you to tie together small blocks of services or microservices to better talk to each other. Kinesis allows us to handle streams of data, whether that's structured streams of data or unstructured streams. Step Functions is a new service that allows you to coordinate a lot of the Lambda functions, run things in parallel or sequential. And more recently, X-Ray allows you to debug and monitor applications and understand their performance. All of these are effectively managed services. Doesn't mean Lambda can't talk to things like EC2 and RDS, but those obviously then have a server component again. So if you're looking to architect a completely serverless application, these are the tools that you can use. And these are being added to all the time. And really, serverless changes how you deliver. So it should eliminate operational complexity. This means that developers can focus just on the code and the application logic. That in turn means they can rapidly iterate and produce new services, bring those to market quickly, which means they've got more time to innovate. And then that feeds back. As they innovate more, they can still get rid of more operational complexity, increase productivity, and so on. So you end up with a very virtuous circle. So some of the capabilities of a serverless platform. So these are the things that we look when we're deploying Lambda and our other capabilities. We have a cloud logic layer. We have orchestration and state management, responsive data sources, application modeling framework. We'll talk a bit more about these later. A very strong and developing ecosystem. You're going to be hearing from some people who have built services on top of that ecosystem today. Integrations library, so how we integrate with existing third-party services. Security and access control, a key part of everything we do at AWS. We have very granular access control on what Lambda functions can and can't do in terms of both calling other services and what they interact with. Reliability and performance, so it's designed to run at massive scale in a fully managed way. And it runs at global. One of the things we've introduced recently is something called Lambda at Edge, which allows us to run Lambda functionality in our cloud distribution network, our content distribution network. We'll touch on that later. So that's really a sort of very brief overview of what serverless is. If you can take one thing away from it, it's event-based compute. So an event happens, a Lambda function runs to do something, that's it. So you've got a very sort of focused microservice that does something that you want it to do. Any questions on that before we move on to the next section? Cool. Okay, so let's look at some of the common use cases for serverless. So web applications, we'll go into those in a bit more detail, but back-end services as well, whether that's for applications or mobile or Internet of Things. How we can use Lambda to do data processing, both in real time, batch, and also some more sort of traditional server types capabilities like MapReduce. Chatbots are becoming more and more interesting, both from a DevOps perspective, but also engagement with citizens. So people may be familiar with things like Slack. We've got ways of integrating with that to allow querying of state and so on within chat. Alexa is our technology that powers the Echo and Dot devices. It's possible for anyone to write their own skill that will allow you to interact with Alexa. All of that is powered at the back end, or a lot of that is powered at the back end by things like Lambda. And then probably where a lot of people start with serverless technology, if you're coming from a traditional environment, is autonomous IT. So this effectively is how you take some of your sysadmin scripts and so on, and you move them into a serverless environment. So if we look at web applications and backends, so this is what we would consider a serverless application. And if I talk you through it, effectively we've got mobile apps, websites, services, all coming across the internet, hitting CloudFront. So this is our content distribution network. This is the one that allows you to deliver cached content from any one of 68 global locations. And then that passes requests back into API Gateway. And then API Gateway will, in fact, let's take the step back. What we have is some of the static content may be stored on S3, so you might present a web page that's delivered from S3. That may have some interactive code that wants to make an API call. That would come through API Gateway. API Gateway would pass it to Lambda. Lambda would do the processing. It would talk to any back-end databases that might be there. It would then pass the result back. API Gateway would return it to the original function, and the web page would be updated. All of these can interact with other services like our DynamoDB data store. All of it is monitored by CloudWatch, our monitoring service. And we also have integration with other endpoints as well, so those services can interact with third-party endpoints on the internet. So a very common use case that pulls together a range of services, none of which require any servers. So all of this is effectively a managed services that will scale pretty much automatically. DynamoDB not quite, but that's near enough. All of those can scale based on your requirements. So one request, 100,000 requests, the infrastructure scales seamlessly in the background for you. If we look at data processing, so this is probably one of the most common use cases we see and where people tend to start with Lambda. This is where you take an object, so let's say a photograph, and you upload it into our object storage service, S3. What happens there is that triggers an event. That event triggers a Lambda function, and the Lambda function does something in response to that event. So as an example, a photograph is taken, it's put into a bucket, a Lambda function will then run generating things like metadata or EXIF data and pushing that into a data store, as an example. That's great and that's straightforward, but what happens if you put 10 photos in at once? What happens is that S3 triggers 10 events, 10 Lambda functions are spun up in parallel to process that data and push the data in. If someone pushes 100 photos in, it scales up to 100 Lambda functions in parallel, pushes the data in, and so on. All the time, all you've had to worry about is that one piece of code that analyzes the data. Everything else is taken from you in a scale-out fashion. So really, really powerful way of dealing with services on demand. When no one's put any photos in, there's no cost. Another form of data processing, we have a service called Kinesis. This is a way of taking streams of data. So this might be a stream from social media, and then pushing that in and very rapidly into other services. So something we released, just reInvent, in fact, is the ability to have Kinesis trigger events in Lambda. So that means we can push things like social media streams into Kinesis. That can push into Lambda. Lambda can do some processing, so it might do sentiment analysis, it might do some metadata around locations, and then store or process that data in other services like DynamoDB. And I think one of our partners today will probably be talking about how some of this is going to be working in their application. Another example, and this is more dynamic data processing. So traditionally, if you had an order processing system, as orders were added into that database, you might have a job that once or twice a day extracted that data, did an ETL, loaded it into a data warehouse, and you could do some analysis on sales figures for that day. Lambda allows you to trigger events in response to individual entries being pushed into a DynamoDB table, and then that Lambda function run on demand for that event. So every time a sales order goes in, a Lambda function is triggered that does the post-processing, pushes it into our data warehouse product Redshift in real time, and the data's there for immediate analysis. So this changes it from a once or twice day with a 12-hour sort of backlog or delay of processing through to a service that can handle the data in near real time. Not only DynamoDB, we also announced recently that one of our managed RDS services called Aurora also now supports Lambda as a stored procedure service. So you can code stored procedures in Lambda, and then in response to those stored procedures, when events happen within Aurora database, you can then trigger Lambda functions. So this gives you a way of being really interactive with your database code. Chatbots and Alexa, we've sort of grouped those together. So this is an example of how we allow users to interact with either a messaging bot like Slack or with one of our Echo services or Alexa services like Echo. So in this case, Alexa tells Slack to send, I'm giving the demo now. What happens there is our Echo device will take that, it will convert it into text, it will trigger a skill via Lambda. That Lambda function will integrate and make an API call to Slack. Slack will then post that message, and then in response, the Slack user might say, okay, that's fine, that message will come back, and out the back says, Kevin says break a leg. So it's a way of interacting and building dynamic services within that chat process. And that can be very interactive. So we've shown another demo where effectively booking a flight to something online, Alexa, I want to fly to Las Vegas next week. Okay, what day do you want to go? The questions come back and forth. Each of those add more context. Each of those in the back-end Lambda is taking that data, processing it, and then determining the next response. So it becomes very much of a tool that allows you to build and model complex services just using very simple building blocks. And lastly, in this section, autonomous IT. So this is where we have services in the past. You might have a script that run backups every hour or every day or so on. In integration with some of our other services like CloudWatch events, you can now write Lambda functions that will do that for you. And Lambda functions, since they can assume IAM rules or security rules within AWS, that means that Lambda functions can have as much or as little permission as you like. So you might give a Lambda function the ability to take a snapshot of a particular EBS volume for backup purposes, but not to restore that snapshot. Or you might set it to reboot a particular server every day, whatever it might be. So if you can do it in code, you can do it in Lambda. And while it's not being run, you're not paying for it. If no one's ever seen the Lambda pricing model, it's probably worth checking out. It's normally a 0 with lots of zeros, and then a 2 after it per event. So some of the customers that are innovating with serverless, it's a big list. I'll let you read through some of those yourself. We will call out just a few of them. So Thomson Reuters are using Lambda to process around 4,000 requests per second. Finra, which is one of the agencies in the US responsible for financial trading, processes 500 billion validations of stock trades daily. And we'll talk a little bit more about that in a minute. Hearst have managed to reduce the time to ingest and process data by up to 97%. And Vivo, which is, for people who don't know, is effectively a music video service for artists, can handle spikes using Lambda of more than 80 times their normal capabilities. Expedia trigger around 1.2 billion Lambda requests every month. Worth mentioning at this point, for customers who are interested, Amazon API Gateway, so if you develop a service that presents your data as an API gateway, this can now be made available in our AWS Marketplace. So whereas before you could present an AMI or a CloudFormation template and then make those services available to other AWS customers, now you can make your data available to customers using your APIs. So just present an API, link it to a plan, and then you can make your data available at whatever cost model you prefer. And that's certainly something that's currently being done by NTT Docomo and F-Secure as well, the URL validation service. Just chatting very briefly about Vivo. So they're using it in 2 locations. So they're using it for their content services. They've developed a microservices architecture that can handle spikes of up to 80 times the normal traffic. And they've also started building a new data platform starting from 0 that is completely serverless. So this builds on the model that we looked at earlier. And that platform went into production in less than 12 months. Very briefly about Finra, because this is one of the highlights of reInvent. 500 billion validations daily. Effectively, they're driven by world events. They typically process up to a maximum of 75 billion elements per hour, but that volume can vary by 2 to 3 times based on time of day or what else is happening. But when the data comes in, they need to validate it meets a certain specification. Those rules are changed and reviewed regularly. Currently, there are more than 200 rules with 100 different derivations. And what Finra were able to do was build a Lambda function that takes each trade and uses that Lambda function to analyze it and then provide that feedback back to the original source. So it means that they can give that feedback very quickly. The original provider can correct that in time so they avoid any of their fines. This was their traditional model using a static Hadoop cluster. And then by scaling to a serverless cloud solution such as this, they were able to move to a model that massively reduced their cost and the complexity. Yeah, I think I've covered those. Just one final thing as well. So this is a shout out to one of our core sponsors, Intel, who are helping us sponsor the collaborative cities. This is an example of how we're using an IoT platform to push data from sensors that are out in the wild. In processing using Lambda, data is being stored in DynamoDB and then pushed back through a proxy layer so people can actually access the information using the client. So this is a partially serverless environment. The top half is serverless. This is more of a traditional type service, but there's nothing to say that that can be recoded for serverless in the future. So final part of the slides, how to get started. So this is SAM. SAM is our serverless application model. I'm not sure how many people are familiar with AWS and what we have. We have something called CloudFormation, which is our ability to define infrastructure as code. So what we've done is we've taken CloudFormation and we've added something called the serverless application model, which allows us to define that in a much simpler way within a CloudFormation template. And that enables us to take functions, APIs, event sources, and data stores and structure them in a very simple format in JSON or YAML that then allows us to publish those services quickly. What this means is you can download and deploy the blueprint using the CLI. You can package up your code and upload it and run it using CloudFormation. It's an open spec under Apache 2, and we welcome pull requests if you want to extend it. This means you can write, you can build, you can deploy and receive feedback much more rapidly than you might do in a traditional environment. We integrate with a range of commercial services, so everything from different code libraries and third-party services through to deployment and monitoring. There are a range of customers who work through our partner network to provide some technology services, and there's also a lot of open source products there as well. Chalice, Serverless, Claudia.js, Apex, and SAM now, which is the one that we've open sourced. Lastly, we have a service called Code Pipeline. This allows you to effectively build your own CI/CD pipeline to push code through a sort of change process very quickly. And that makes use of things like GitHub or S3 or Code Commit for storing your code. Code Build will then build and validate that on its own or in conjunction with third-party tools, and then deploys using CloudFormation and SAM into production. And that's it from me.
So Lambda will spin up all the servers on behalf of us, but some of the features require some initialization, like bootstrap. Is it possible? Like, it might take some time for, if we ask Lambda, it will create all the servers, and then we instruct them, okay, initialize the software, or maybe in your Photoshop example, it requires some software to be installed to do some thumbnail. So rather than doing every time, can we do some bootstrap on initialization?
Yeah, so Lambda is a serverless model and it's a stateless model. So you can't assume that state can be maintained between Lambda functions. If you're going to be running lots of Lambda functions, you can define certain code and certain calls outside of what we call the event handler function, which means that it won't be reinitiated every single time. Although as it scales in the background, that may require new containers to be built out in the background, which will require that. But in order to maintain state, so if you need to do any sort of initialization, that has to be done in code. If you want to maintain state, we recommend a service like DynamoDB or S3. But in response to that photo application, for example, say you wanted to do a transformation from JPEG to PNG. So what you could do when you package up your application, you can also package up your third-party libraries or any sort of custom code that you need to do this. Part of the application model then uploads that code as a package into S3, and then that is placed into the Lambda function when it executes. So you can package up third-party code as well, not just the stuff that's available within Lambda natively. Does that answer your question? So you can.
But it still might take some time.
So yes. So if you're doing something really complicated, then it may be that it takes a little while to initiate, and so that's part of your trade-off to understand, what needs to be initiated, what needs to be bootstrapped, and what can be done on the fly. And part of architecting on serverless is to understand, could that bootstrap be broken out into perhaps 2 or 3 events that could be chained, each of which will have a lower execution time. Lambda functions can run up to 5 minutes in length, and we basically, there's 2 charging axes, I suppose. The first is the amount of memory you allocate to that Lambda function, and the second is how long it runs for. And we charge a Lambda function at 100 millisecond increments. So if your application runs for 280 milliseconds, we round up to the nearest 100, 300 milliseconds. And if you've used it within 128 meg of RAM, then you'll get charged of 300 milliseconds worth of time. And that figure is actually very low. So we include, I think it's for 128 meg, there's a free tier of 3.2 million seconds per month that you can use Lambda for. So it gives you the capability to do a lot of things. We can talk about this a bit more, and Rodrigo's around, so you better answer some questions as well on that one.